All right, in this lesson, we'll explore how to retrieve rows from our data frame using the index labels. And we'll be using something called the loc method to do that. I'll begin by re-executing our code to import our James Bond dataset. And I'm actually going to add two tweaks here. The first is adding that index call parameter, which is index column, and specifying that I want to use the film column to the left as my index labels. So that's what my data frame looks like currently. And there's one additional operation I'd like to do, which is sorting the index alphabetically. To do that, I can call the sortIndex method and make sure I add that inPlace equals true parameter to make it permanent. And that's going to give me a data frame where the index labels, which represent the film names, are sorted in order. Now, the impact of this isn't really going to be dramatically felt when we're dealing with a data frame this size, and by that I mean 25 rows. But whenever you're dealing with something much larger, for example 25 million rows, sorting an index can greatly accelerate the extraction process. The reason for this is because pandas can think more logically when it wants to find the specific label that it's looking for. If a label, or rather an index labels, are unsorted, it's basically going to have to go through all of them and check them all one by one to see if they match your query. In comparison, when a index is sorted, pandas knows that everything is structured in a specific sequence, and it can jump around specifically within that index and find the exact value that it's looking for much quicker. Now, there's much more complicated technical stuff going on behind the scenes, but just from our user perspective, for our own sake of speed and having things as quickly and efficiently as possible, I strongly recommend sorting the index of your data frame if you're using something like strings as we are here. That's just the best practice to stick to. So let's go on right ahead and talk about the loc method. The loc method is called directly on our data frame, so it's going to be bond.loc. And this is one of those rare examples where a method actually does not take parentheses. It's actually going to take square brackets. I think the reason that they did this is to maintain consistency. We know that square brackets are usually used for some kind of extraction process. When we use them on a series, we can extract a row. And when we use them on a data frame, we can use them to extract columns. So I think they wanted to maintain that consistency, but since the regular bracket syntax already is used for columns on a data frame, we have to use the .loc method to extract rows. So let's say we want to pull information for the film called Goldfinger. I'm just going to enter it in double quotes here. It's going to look for that index label right here. Whenever it finds it, it's going to return that row's information. And if it's a single value like this, pandas is actually going to return a series. And if we take a look at the series, we can see that the column headers from our data frame right here have become the index labels of our brand new series. We can see them to the left right here. And to the right, we're actually going to have the values for that row. So for the row where the label is Goldfinger, the year value is 1964, the actor value is Sean Connery, and so on. So that's a single operation. Similarly, if we want to extract another film, let's say GoldenEye, it's just going to be the loc method, a pair of square brackets, and the name of the index label in double quotes. Now, a few notes here. If the film that we cite, or in this case the label that we cite, does not exist, for example, Sacred Bond is not actually a real Bond film, there's going to be an error in that case. Pandas is going to be unable to find that key among the index labels. It's going to give you this ugly blob of text. So I'm just going to comment this out to ensure that we don't have any errors and move on. And in addition, if we have an index label that's represented more than once, for example, Casino Royale, in that case, it's going to return all rows that fit that condition. So unlike Python dictionaries, pandas data frames do not have to have strictly unique values in the index. As I mentioned way back when, this is one of the great features of pandas is its flexibility. It's a lot more open to these kinds of things. So whenever you enter a label name to the loc method that is duplicated, it's just going to return all of the rows that fit that label. In this case, because we have more than one row, the end product is going to be a brand new data frame rather than a series. Let's also talk a little bit about extracting sequential values or values in a row. Let's say I want to extract, with the loc method, all films between Diamonds Are Forever, which I think was 1971, and Moonraker. So I'm going to put that colon in the middle, which is the same Python list syntax for extracting sequential values. And you can see that we're going to get all the films from Diamonds Are Forever at the beginning and Moonraker at the end. Now what's really interesting here is that the Moonraker part here is included. It's inclusive. So that last value is part of our data frame. Many times when we're working on with a Python list, for example, that last value is going to be exclusive. So it's going to go up to that value but not included. Whenever we're working with strings as our index labels, the end value is included. Similarly, we can do something like extract every movie after GoldenEye. We can do that by doing GoldenEye and then using a colon, which indicates go to the end of the data set. So here we're going to have GoldenEye at the very beginning, and we're going to proceed all the way to the end of our data set. And the reason that you see all these different movies is because we have it sorted here by alphabetical order. So it's going to start at that G and proceed all the way downwards. Similarly, if I want to extract every movie from the beginning of my data frame to, let's say, On Her Majesty's Secret Service, not Majesties, On Her Majesty's Secret Service. Let's see if that works. Similarly, that's going to extract all the movies starting from A up until we get to On Her Majesty's Secret Service, which is going to be the last movie here. And in addition, we can also extract multiple non-sequential values. So, for example, if I wanted to extract two movies that are not next to each other, I can once again use my loc method with my, with my square brackets to extract. And then within those square brackets, I have to give another pair of square brackets, which is going to represent the list of movies that I want to remove. So let's say I want to do Moonraker and Octopussy. Everybody loves Octopussy. If I do that, we can see that we're going to pull those movies out of the data frame, those two index labels. And in this case, they are in the order in which they appear in the data frame because it is sorted alphabetically, but it doesn't have to be this way. If we wanted to pull Octopussy first, in all seriousness, Octopussy, as far as I recall, was actually a pretty terrible Bond movie. But let's say I want to pull Octopussy first and then do Moonraker after, we can do it this way. And even though Moonraker comes first in our original data frame, because we pulled it in this way, we're going to extract those labels in the specific order that those names are passed into our internal list. There's one big caveat here that you should watch out for. I'm going to use bond.loc again, and I'm going to use my square brackets and another pair of square brackets for a list. And I'm going to begin with two Bond movies that actually exist, which are For Your Eyes Only and Live and Let Die. And then I'm going to add a Bond movie that actually does not exist, so it does not exist in our original data frame. Let's call it Gold Bond. When I do this, we'll see that the first two movies, these first two index labels, are going to be extracted, and the last one, which does not exist, is going to be included as well. You're going to see these null values to the right here, all of these NaNs, and that might give the impression that it's simply an existing row and all of the values are blank. But it is not. Gold Bond does not exist in our original Bond data frame. It's been intentionally added to our new data frame right here. And that's something that you have to be very careful with. Whenever you're extracting multiple index labels with the loc method, if at least one of them exists, you're not going to get an error. So be careful whenever you're doing multiple values, because just because it shows up does not mean it's actually an index label in the original data frame. A classic way that we can check whether this exists is, of course, using our Python in keyword. So we can do gold bond in bond.index, which is our attribute, which gives us that object that represents the index of our data frame. And there we'll see that false, it does not exist. So just be careful. So that's how we can retrieve rows by the index label name using the loc method. We can use the one label at a time, multiple labels in a list. We can do from the beginning of the data frame to a specific label, or from a specific label to the end of the data frame. Whichever way you want, we can extract them in different orders, but that's how we extract them by label name. And in the next lesson, we'll introduce the iloc method, which can be used to extract rows by index position.